So today I'd like to talk to you about how we're planning to do building robots in FSE100 Introduction to Engineering over ASU Sync. Now, this project is called FSE100 Project Spin, and the idea is that students are working for a ride-sharing company called Spin that's looking to get into autonomous robotics, and one of their challenges is how do you pick up people with disabilities that are in a wheelchair, right? They want to be accessible and have that available. So the requirements get discovered and the students work on developing, designing, and programming a robot that navigates a city, which is really just a maze in one of our labs. They locate a pickup area, pick up a passenger in a wheelchair, then they navigate to a drop-off area, locate it, and then safely drop off the passenger without dropping it. Right, and this is a great project. It is super exciting, and everybody is pumped about watching the robots run around. People get crowded around the maze during demo day, just like this picture here. You can see me with shorter hair, non-corona hair, and in times when we could all share in the excitement in person. So we can't really do this anymore, right? So what we're planning on doing is making a couple critical changes to this. And the first one is we're planning for blended teams, Zoom and in person, and to make sure that at any time, if something goes wrong or if we have an outbreak on campus, we can switch to entirely remotely and still complete the project without any issues. The next thing is that rather than students building the robots themselves and every team getting a kit, they're going to choose from pre-built robot designs. So we'll have 3 designs available and they can propose a 4th one, but they have to give detailed enough instructions that our TA can construct it. They don't construct it. And the reason why we're doing this is so that we don't have to disinfect every kit. We don't have to worry about spreading disease through the kits. Having a limited number of profiles or robots available also allows us to have a centralized construction and centralized testing, which is our next part. We can have our programming and testing done in simulation. One of our excellent lecturers, Doug Sandy, has produced an incredible 3D simulator that allows us to do realistic simulation of the robots in a simulator, and it's nearly as good as the real thing. It's really, really powerful, and it's a huge advantage is being able to do that in simulation. That way students that are remote can be coding with their teammates, they can be doing testing with their teammates. We don't have to rely on that one person that has the kit either at home or is in the lab, and everybody can be contributing at this point. One thing we want to do to facilitate this and make sure that all of the people, remote and in person, are participating is have daily goal setting. So we want to have a meeting. I'm going to have a meeting with my students. Each of the groups and my TAs will be helping with this as well, is at the beginning, we want to make sure that everybody has daily goals and individual responsibilities that they're committing to complete. And I'm going to take note of these as we go. And these labs are 2 or 3 hours long every week, and we want to make sure that they're making sufficient progress over that time. So making sure that they set goals, that those goals are reasonable, they're not going to be too big or too short for the time allotted, and that everybody has some contribution and is going to be working on it. And they make that verbal commitment. That helps make sure that they're aware of what they should be doing, that they are committed to what they're doing, and I can check in on it later. And then finally, we want to do scheduled real-world testing. So we're going to have a centralized testing with a TA that the students submit. They have to document their tests, and that includes the code that they want to test, the robot that they want to work on, a robot model that they want to work on, and the test configuration. Where do they want the robot to be? Are we going to pick up a person? Are we just doing maze navigation? That sort of thing. And now the TA will schedule a time block for that particular team. And this allows us to limit the number of people that are around the maze because it's a central robot that the students as a whole are not allowed to touch. We can make sure that we keep it hygienic. The TA will be wearing gloves, disinfecting the robot at the beginning and the end of lab so that it doesn't spread between classes, and that the students do this. And this is actually what we're excited about is from a software development perspective, this is a good process for thinking about how we're going to do a test. You do your sort of short loop testing and simulation, you get some feedback, you see if you think it's going to work, then you try it out in the real world with a focused test that is now expensive rather than it being like just a throwaway. And it used to be we'd have 20 people crammed around the maze, which is not very big, it's the size of a dining room table, and everybody would be elbow to elbow and crammed in there, and they could run whenever they want. Now we're not able to do that, so now it's much more expensive. We want to make them think about the test that they want to run, and this is really good practice for the real world. And then finally, the students that are remote, if the team is remote entirely, we have cameras set up in the lab that are IT is provided, and they allow us to see into the maze. The students remotely can see into the maze, and they can watch their test being conducted, seeing how it's behaved in the real world. So with all of this, the only person that really needs to be in the classroom is me and the teaching assistant, and the rest of the class can be remote if they want to be. We're providing the option for them to be present in class. The expected challenges that we have here is there's a tool learning curve. These are freshmen. They're going to be learning Zoom. They're going to be learning programming. They're going to be learning the collaborative programming tools that we have available. That's going to be a steep learning curve. The engagement during lab is challenging. When we were doing this in the spring, we had a older version of the simulator that was more challenging to use, and students quickly got discouraged and they would go and do something else. Keeping them engaged, keeping them updated, making sure me and my TAs are talking to each of the teams, and I will be doing this on Zoom. So everybody in the classroom and on remotely will be on Zoom, and I'll be visiting with them, not really in person. Even if they are in person, I will come over, social distance, make sure that they can hear me on Zoom, and we can talk about the expected challenges. There's wireless mics available in most of our classrooms that enable this. And keeping them engaged by checking in regularly and seeing what they're working on, making sure they have a channel for us, me and my TAs, to respond to any questions that they have very quickly. Engaging and encouraging the collaboration between in-person and remote students is going to be challenging at first, setting those expectations early on and modeling it by talking about what they should be doing, setting those goals, thinking through it with them about, okay, what are you going to do in person? What are you going to do online? How are you guys going to work together? How are you going to communicate? When are you going to check in? That sort of thing. And then one of the biggest challenges is international students and time zones. If we have students that are attending from the other side of the world, which is very likely to be the case, how are we going to collaborate and do time-based work on that? Working with the students to figure out what their schedule is like, if they're able to attend in person. If not, what can we do to assign them tasks? How can we provide help that's available through after hours sort of communication channels like Slack or Canvas discussion boards? How can we support those students to engage when their conditions are very, very different? And then the sort of organizational overhead here is these check-ins take time, the planning takes time, there's conversational overhead, there's scheduling, there's forums, there's all kinds of stuff like that. Zoom fatigue is going to set in because it's more of a social stress to interact in this way. That's going to be a real challenge, and the expectation is everything is just going to go a little bit slower. Have low expectations for development, take our time, be patient, and work through everything the best that we can, and setting those expectations with the students, right? Not saying, you don't have to rush through this. We're going to take our time with this. We get as far as we can, and if you've been teaching this class for a while, it may go slower than it did before, and that can be really challenging. So if we consider all these challenges and expect them, there's going to be things that we don't know, and we just have to adapt as we go. And I'm planning on having a follow-up to this once we get through the project a little bit and we can see how it's going and how we're adapting and what tools exactly are proving to work well and what are not, that we'll be able to share a lot more of our experience.